Okay, I'm going to do a couple of examples involving number lines because I don't think we did enough practice in class, and the test that we're going to do does have a couple of number line questions. So I'm going to do a few examples of different types, so hopefully people can visualize what we're supposed to do with this. So the question we're going to start with is all positive, so basically it's 6 plus 9. It would be really simple, except when we talk about integers, people sometimes get a little flustered. So we're going to the answer is 15, but how's it going to look on a number line? So the first thing you should do is to start with 0 and look at the first term. And it's positive, so you should be expressing it in a positive direction. And the number you should get to is positive 6. And from there, you look at the sign and decide which way to go. So anything that seems like adding or involves a positive integer should be going in the right direction. And then anything subtracting or involving a negative integer should go in the left direction. And because this is all positive, I'll choose a different color just to see. From this position of positive 6, we should be going an additional 9 in this direction. And where we're going to end up is right here. That's positive 15. So that's going to be our answer. So the answer to this is positive 15. It's sometimes good to work it out before you involve the number line, because especially if you're not comfortable with number lines, and solve it, and then you know where to end up, and then you just have to figure out how to show it, or how it's supposed to look on a number line. So if we were doing the same kind of a problem with tiles, we would be starting with 6 positive tiles, and we would add an additional 9 tiles. Is that 9? Yes. And then just count them up, and the total will be 15. 15 tiles. Problem, we're going to involve a negative. Now the way they work, obviously we're starting with the first term. So just like in the first case, I'm going to make sure that I express the first term, and then from this point we have to figure out what direction to go. So last time we were adding, so we were going toward the positive direction, and we're adding again, but this time we're adding a negative. Every time you see a negative, you do the opposite. So I was going to add, but now because it's a negative number, I'm going to switch and go to the other direction. So again, I could solve it in advance if I'm a little concerned, so my answer is going to be negative 3. So somehow my solution has to show negative 3. So I'm going to add my negative integer, and I'm going to wind up in here. Negative 3. Okay, right there. So that's how I show this. And again, if this was a tile problem, I'm going to show tiles as well, just so we don't waste time here. Tiles, so I have 6 positive tiles. I'm going to add 9 negative tiles, and then we're going to remove any 0 pairs to simplify it. And the remainder, this, is negative 3. So that's how I do it with tiles. So if we go back to this slide, the number line looks the same, but the tiles look different. Here I'm removing lots of 0 pairs, and then in the next slide, the one I was just working, here's where things start to get a little complicated, but this answer is actually exactly the same as the last problem. What's happened is these two guys have switched. And even some of the problems we did in class, we talked about rearranging the question so that it looks like this. And in problems like this, I wasn't quite sure how that was supposed to help, but it does kind of show you what it should look like on the number line. So again, positive and negative territory. Start with 0, move in the direction of the first integer, move the direction of the first integer, and then from here, you have to decide what you're going to do. Now I'm going to look at the original problem. I'm going to look at this one and talk about it in terms of that. It says to take away positive 9. So it is a positive number, but because we're taking it away, again, we're going to be going in this negative. Whoops. We stick with the same color scheme here. we're going to go in the negative direction and again wind up at -3. Okay, so we're going in the negative direction 9 units and we end up at -3. And with tiles it looks a little different. I personally prefer tiles because you can actually show what's going on. 1, 2, 3, 4, 5, 6, 7, or 6. And so there's my 6 yellow tiles representing 6 positives. And now I have to take away 9 positives. Well, I can't really do that until I add some 0 pairs. So I'll add 0 pairs. Sorry, this is taking so long. Until it's possible. Whoops. And add 0 pairs until it's possible to do the action. They want me to take away 9 positives. Well, now I have 9 positives to take away. So I'm going to subtract all this. And that leaves me with 3 negatives. -3. I should show it like that. Now, notice that if I go back and look at the... So here, it's actually looking a little different. So I like the tiles because they can... you can distinguish between the two problems. They look a little different even though the answer winds up the same. And we have this one, which subtracting the negative is going to be the most confusing. And even the textbooks don't like to go too far into it. The extra worksheets don't show how to subtract negatives because nobody really knows how to show it, so it looks proper on a number line. So even though we're going to have to do this, it's not very intuitive. So again, I'm going to make sure I know this is positive direction, negative direction. Same as before, I'm going to state the first term, start at 0 and go to +6. So I've already figured out my +6. But now it says, and I've got my red pen ready, it's telling me to start at 6 and then subtract. And so at first I think I want to go in this direction, but it turns out I'm subtracting a negative. So I'm going left, but then I have to do the opposite because I'm subtracting a negative, which is just like going positive. So really, instead of going in that direction, I'm going to go, as in the first example, in this direction. So my final answer is going to be +15. And if that blows your mind, then maybe it's a good idea to solve this problem first. And what the textbook solution to this seems to be to simplify this problem, which is to take your +6, then subtract a negative. That means I can switch both of those terms. I'm allowed to change this term and this term to its opposite and proceed. So it turns out to be exactly the first example, and honestly the number line doesn't look any different than the first example. So they're both the same, the way it's supposed to look on a number line. And again stating why I like the tiles so much, I'm going to put 6 red tile or yellow tiles out to represent the first term, and then I'm going to subtract negatives. I'm going to take away 9 negatives. Of course, when I look at it, where are the negatives? They're not there, so I'm going to have to add them in. So I need 0 pairs until it's possible. So I need 1, 2, 3, actually, I'm only allowed to add zeros. So here's 6, 7, 8, 9, and here's and what you see here, those are my negatives and those are my positive 0 pairs. And I'm only adding them so that I can whoops, I'm doing something wrong. I need to subtract 9 negatives. I don't have enough 0 pairs. So keep going until, actually I need 9 negatives. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 8, 9, and I need them to be 0 pairs, so I need positives to go with those negatives. And now is it possible to subtract -9? Yes, it is. These will come out. And I have the 15 positives, so the answer to this is +15. So hopefully that helps. We've got the number line and the tiles in there, and the last example was the toughest, but it turns out it doesn't look any different than the first tile, or the first example with just adding.